Color is the characteristic of human visual perception in which describe the categories of color named such as red, blue, and green. Color is very significant in our daily life. It can be found everywhere, from our skin tone, the food we eat, up to the three lights of a traffic light. It is an attribute of light which is specified by the light's wavelength, and it varies with every color. Our proposed project is consist of three base color which is red, green, and blue. These colors are capable of producing another five different colors by combining the two or the three colors, thus resulting to a number of eight colors. The primary purpose of this project is to help color-blinded people in determining the color output by the help of the 7-segment display. This project aims to use the knowledge developed in class to make something that will show the relevance of color in everything that can be seen. The project will involve topics such as binary numbers, logic gates, and combinational logic. It will allow the students to practically apply and not logic gates, BCD counter, and 7-segment common anode displays and decoders to a working circuit. The project will compose of a sensor, a circuit, and a display. The LDR light-dependent resistor will act as the sensor. The 7-seg display will indicate the color of the result of a sensor and an LED, and the ICs of logic gates of and not. The sensor circuit will be able to detect and discriminate only up to 8 color, namely black, red, green, yellow, blue, pink, cyan, and white. The input is to be fed through a sensor which is made up of LDRs and color filters. The use of a convex lenses and glass filters will further improve the function of the sensor. But because of the difficulty in producing this, the convex lenses will be unavailable while colored cellophanes will be the alternative of the colored glass filters. LDRs, or the light-dependent resistors, are resistors which have varying resistance depending on the lumens absorbed. An LDR's resistance is directly proportional to the lumens detected, which means that when a light is pointed to the LDR, then it will give off a high resistance. The filter is for wavelength selectivity. It will allow only the wavelength of the color of the filter to pass through, thus triggering the LDR. The next part of the circuit is the processing of the 7 signals received by the LDRs. The process involves NOT and AND logic gates. The different inputs from the LDRs are processed here to give off outputs. Aside from the logic gates, NOT and AND, decoders for 7-segment displays are included in the main circuit. From 3 inputs, the circuit will come up with 8 outputs. These 8 outputs are to be displayed with the use of 8 different LEDs of the color to be detected and 3 7-segment displays that will show a 3-bit binary representation of each color combination. Zero 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 represents the black color. For a binary number of 001, we have a blue color representation. For 010, we have color green. 011 represents the color of cyan, and we have 100 for the red. 101 for the color of pink. 110 is a representation for yellow. And lastly, 111 for color white. And this is how our circuit looks like in PCB. As we can see, for the output, LEDs of the desired colors are available and will activate once the sensors distinguish the color tested. Aside from the LEDs, the three 7-segment displays will show the binary representation of the color being tested. These 7-segment displays are connected to the circuit using each a 74 LS4 7D IC, which is a 7-segment decoder. The inputs of the decoders will come directly from the LDRs. Each decoder is connected to an LDR. The decoder is configured in such a way that the output display of the 7-segment display is binary. The circuit itself is easy to construct. The only hard part is the calibration of the LDR and proper usage of the filter for the LDR. We have observed that it is required to have a dark room for the color sensor to work properly. We have tested it several times until we managed to construct the best filter for our LDR. We turned off the lights during our demo and projected different colors on the LDR. The results were accurate as we expected. The video demo proves that our circuit works properly. Overall, we managed to acquire our expected result for our project, and we are pleased on our hard work and dedication for this work. The design functioned as intended with only a few difficulty experienced. The circuitry itself is designed to the best specifications needed, but the sensor used was troubling since the sensors lack a good class of filter and a convex lens, which is a huge factor. But despite the lack in materials, a substitute of cellophane as a filter and the disregard in convex lens still gave good results in the output as long as the testing environment is dark. It is also recommended that the use of a good quality filter and a convex lens be used since it helps in discriminating colors. Also, testing environment must be dark for better light detection. And lastly, for more colors to be detected, the sensors must give off a signal that has an intensity and not only in highs and lows.